begin with Chapter 5, looking at business-to-business e-commerce. All right, so agenda for today, we're going to do a quick review again, like I do every session, and then we'll look at what was not covered in Chapter 5, but I certainly believe should have been, before we get into Chapter 5. All right, so let's go. So the review. In chapters 1 and 2, we kind of covered the basic internet, what it is, looked a bit at the technology such as TCP/IP and domain names and domain name system, the history of the internet, and tried to get a big picture of what's going on. Chapter 3, we looked at the basics of e-commerce, starting with the different revenue models and looking at the web presence and how do you develop that. And then in Chapter 4, we went a little bit more depth into the marketing side of things. So up until now, we've focused a lot on the consumer side of the web. Today, we want to take a look at more of the business side, what's going on inside a lot of businesses and between businesses in particular, because there's a lot of really interesting things going on here. Now, what wasn't covered in Chapter 5, but really I think should have been, and I suppose you could have put this into a different chapter, and maybe the authors will come up with a new version of the book where they will include much more on this. But if you're going to talk about B2B today, you really need to start talking about these two concepts. I believe it's absolutely essential. And what are those two concepts? Number one, service-oriented architecture, or sometimes not just the whole architecture, but service-oriented computing. And second is cloud computing. Now, if you read any IT magazines today, or watch any IT news sites, you're bound to see these two terms popping up all over the place. And I think it's rather a travesty that it's not in this book, because I believe they're absolutely essential to really figuring out what's going on. So we have service-oriented architecture and we have cloud computing. Two interrelated concepts. They're slightly different, although there is some overlap, which we'll get into. So first, before we really talk about what are these two things, we really need to dig into what is a service. Not just what it is, but why do we even care about doing services? So let's start with this. What is a service? A good definition of it might be an independent software programming executing a unit of logic. You can think of it as a container for some specific function. You know, there's some code being generated that's going to do something, and we're expecting multiple different people or different other programs to use this in different ways. We don't necessarily know which programs are going to be using it, but we want to create this out there. Now, this really gets into why are these services important? Because it changes programming from a product-based idea to a service-based idea. So if you remember back in Chapter 3, we talked about in our revenue models, you can sell a product or a service. Well, what is this in terms of programming? What does it mean? Well, traditionally, when you created a piece of software, you completed it as this finished product that you delivered, that you handed off, or you put in a package and sold it on the shelf, or you handed it over to your clients so they could use on their computers. Okay, and this is, for many, many years, this has been the tradition within the programming industry to do this, okay, the software industry. That is shifting to a service-based idea, okay? And by a service, what you're doing is you're providing some skills or some functionality or some capabilities, but you're still maintaining the control over that service. Okay, over the quality of what goes on inside of it. Now, why is this so important? Why is this so useful? Well, number one is this idea that, all right, if we deliver it as a service, the service we can make available 24/7. If there's any changes that need to be done to the service, we can do it immediately and take care of it and fix it. And this is also a lot easier to start thinking in terms of we can switch out one service for another. It's easier to swap or to change, which gives businesses a great deal more flexibility. And that is really kind of the focus of the service-oriented, to create services, why you might want services. Okay, you want to give people that flexibility to be able to use a piece of code over and over and over again in many different contexts. So services, basically, how do they work? Well, services accept messages. And this can be a message in the form of input data or a command. And then inside of that service, it performs some capabilities, some logic, some functionality. It does something. And then it sends a message back. And in that message might be usually some output data. So the possibilities and limitations of the data and commands sent and received constitutes its interface. And so today you'll hear the term an API, which stands for Application Programming Interface. And if you haven't heard of this term, take it to heart, because you will see this many, many times throughout your career. In fact, you can easily start getting an idea of what an API is. If you go to Google, here's Google code. They have APIs for all of their major applications. Okay, so their Ad Exchange, AdSense, Blogger, Books, Calendar, Cloud Storage, Drive, all these different programs, they have an API. And you can actually click and learn about their APIs on each one of these. Okay, most new software today has this built into it. And the idea is we want to provide this piece of software not just as a product, which sometimes they still are, but also as a service so that you can use the software, tap into what's going on inside of it, use that functionality, use the logic that's already built. So we don't have to rewrite it. And so how are these accomplished? They're usually done within things called components or web services, and there's even something newer called REST services. Okay, a lot of interesting things are going on, especially online. You'll find that a lot of software created for online is being done either using a web service or REST services. But it doesn't have to be online, and that's why I want to focus on components. Like, for example, Microsoft Word, Microsoft Access, Microsoft Excel, they all have an API interface, or the API, the Application Programming Interface, so that you can use some of the functionality of those programs and then work with those programs by creating your own software that integrates with it. I did that once several years ago with project management, their Microsoft Project Manager. Microsoft Project, sorry. It's called Microsoft Project. I did it for project management software I was working on. And so we could actually input and export data from Microsoft Project. So if you want to kind of visualize, for those of you who are a little bit more visual thinkers, you can think of it as this messages. That's these little things flying in. There's little packets that come in. There's a message processing logic that says, all right, here's this new message. What are we going to do with it? And basically it can interpret it and then sends it into the core service logic where it actually does something. That's where the actual functionality is located. Once it does something, if anything needs to be returned, it will be, and sent as an output message. And sometimes those output messages can just be as simple as done. You know, if you expect the input is go do this, it does it, and then sends the message back saying, all right, I did it. You know, and sometimes they are that simple. Sometimes it can be far more complex. And for one example is if you use Google's Maps API. You can actually interface with that to add data points on a map and then have that map returned with all these different data points or different directions or whatever. So now that we've kind of gathered what the basics of a service is, let's dig into service-oriented architecture. So what is service-oriented computing? So even before I talk about the architecture, let's talk about service-oriented computing, because it's a building block to understanding what the architecture is. Well, if you think about it now, if we start creating one service, couldn't we create a bunch of different services? Okay, and so when you start thinking about service-oriented computing, what we're doing is thinking about we're creating a bunch of different services that all interact with one another. And oftentimes they interact to create a larger application. So you might have 3 or 4 or 5 different services that are all working together to do some larger purpose than what each individual service was designed to do. Okay, so some larger application. And it's often very distributed, so it doesn't have to be on the same server. They could be on many different computers. You might have one on a mainframe, one on a Linux box, and maybe another one on a Macintosh, right? These services are all running independently, but we can pull them together by sending messages back and forth between them. And maybe you need to create a third piece of software that does this communication between them. That's what service-oriented computing is, all right? So basically, services can be reused by various applications, and the same service might be used by 4, 5, 10, 100, 1,000 or more different applications, just depending on its need throughout the organization or the need throughout business partners. So how is that different than service-oriented architecture? Well, I got a little video I found. We'll watch that real quick. And actually, I've already opened up the link to it. And so let me rewind here. Hit play, large size. Let's watch.
Service-oriented architecture is a distributed model for building and managing enterprise software. Its guiding principle is that applications, when practical, should reach across the network and call upon the capabilities of discrete pieces of software known as services, rather than programmers creating those capabilities again and again for every application that needs them. Organizations determine what services they should create by analyzing their own business processes and software assets. For example, a company may have dozens of purchasing processes, each of which includes a step where electronic purchase order is created. Instead of programming the same PO routine into each purchasing application, that capability can be built once as a service and shared, reducing effort, ensuring consistency, and providing a single point of control for changes in purchase order format or business rules. The ultimate payoff of service-oriented architecture is business agility. Developers can construct new applications to meet specific business needs quickly by drawing on services built on a variety of platforms. This loose coupling is possible because services are wrapped in standard protocols and interfaces so that a service can be invoked at runtime without specific knowledge of its platform or programming language. Services may be written from scratch, licensed from a vendor, or abstracted from existing applications, many of which run on legacy systems but, thanks to widely available development tools, typically require minimal effort to provision as services. Once services have been tested and deployed, they're published in a directory so that other developers can find them and use them in applications. Integrated with the registry is a repository that holds metadata about those services, including details about how their interfaces should be constructed, what service levels those who invoke a service should expect, who maintains the service, and so on. The most challenging aspects of service-oriented architecture are organizational and cultural. Enterprises are now struggling with such issues as what it means to own a service and how an owner should respond to requests for changes to that service from others in the organization. But many enterprises are already seeing the benefits of improved business agility, and their successes have made service-oriented architecture a dominant trend in enterprise information technology.
Okay. So that is a quick video clip And it doesn't really answer the question really well as far as what is service-oriented architecture as compared to service-oriented computing. I did a little bit there at the end. They covered a lot of ground. But simply doing service-oriented computing does not mean you have an architecture for doing it. So what does that architecture imply? Well, you have to have some overall plan for service design, development, deployment, management, and organization of all these different services. So one example they brought up was who owns a service. So suppose one department develops a service, who can use it? Usually we want to leave that open for everybody, but not necessarily. It just depends on the type of organization. Now, if you are, let's say, a General Electric with many different types of businesses that are all conglomerated together, you might develop a service through one line of business. Can the other lines of business use that service? If so, how do you manage changes to the service? How do you know who's using that service? And if you make a change, how do you let everybody know that a change has been made? Are there cases where the development needs to be done in tandem? Lots and lots of questions about how to deal with service-oriented computing. And the architecture is a way to help organize an overall plan. Okay, kind of like an architecture for an overall plan to a building, right? There's so many different things that can go on in a building that you got to have this all coordinated. And the same idea happens with service-oriented architecture. And that in and of itself is a very, very difficult but interesting topic that a lot of businesses now are struggling with. They've already started moving to service-oriented computing. Now the question is, how do we create an architecture that allows a continuum of use of our services without our business people and our IT people going crazy trying to manage it all? All right. So that is a picture of SOA. So it does, let's be clear about this, okay? SOA does not have to be internet-based. Although it usually is, it does not have to be. And that's why I talked about components, software components, or like Microsoft Project. Okay, it was not an internet-based component, even though it was being offered as a service. But services usually are platform independent, which makes it very convenient to move to the web. And in fact, a lot of services now are doing that. And I don't know if we went into too much detail about this earlier, but there is a technology out there that's internet-based, designed for data transfers. Okay, I think if you read your book, they talk about it, and I don't think I talked about it in the lecture at the time. That technology is called XML. Okay, XML, which stands for Extensible Markup Language, is probably the best platform for internet-based data transfers. And if you do any type of service-oriented computing, you're going to have to know XML, because that has almost become the standard way of sending information over the web. Okay, not the only one, and there are a lot of other ways of doing it. And if I ever do teach a class on services, that's going to be one of the things we talk about. But that being said, XML is widely used primarily for that purpose. So here's something that you're probably already a little bit familiar with, is object-oriented architecture. So hopefully all of you, or if not already taken, are in the process of taking the programming class here at ECU. How is SOA? Now think about this. Take some time and really put some thought into this. How is SOA similar to object-oriented architecture? So think about object-oriented programming. How is that working? What are objects and how do they communicate with other objects? And if you want to take a minute to pause this video to really sit down and think through it, I encourage you to do it, because I think it will really help you understand this concept. But when you're thinking about it, we've already saw that diagram earlier, which says we're sending messages to this little piece of logic. That's essentially the same thing that's going on within an object-oriented programming. You're sending messages between different objects, right? And inside that object, different programming logic is doing different things with it, with the data, and sometimes sending messages back. So, but how are they different? So that's the similarities. They send messages back and forth between different components or objects, right? How is it different? Well, service-oriented implies that these are independent pieces of logic. Object-oriented programming doesn't necessarily, they might have objects in the sense that in some sense, they are independent, self-contained pieces of code. They are self-contained, but they're not independent. In other words, you can't just pull an object out of a program and expect it to work. That is not true in service-oriented architecture. They are expected to be independent. Now, that decoupling idea is something that's important to object-oriented programming, and you do want to try to decouple, okay? But there are cases where coupling is important and has to be done. A second thing that's different, in service-oriented architecture, you are specifically trying to work with other pieces of code. You're supposed to, the idea is to leave yourself open so that other things can connect to you, and oftentimes many different platforms are connecting to you. In object-oriented programming, although this is not 100% true, 99% of the time you're working on one platform, okay? But hopefully you can see that there are some similarities, and I do believe the service-oriented architecture was inspired in a large part by object-oriented architecture. And so you will see a lot of similarities. They are different because services are focusing on providing something as a service versus an end product, which is more object-oriented related. So now we're going to move on. So that's kind of the basics of service-oriented architecture. Let's talk about cloud computing. Getting a lot of hype. Honestly, I think it's getting a little bit too much hype. But let's talk about what it is and why it can be useful, and then we'll talk about some of its limitations. So cloud computing essentially is an internet-based computing shared through use of services. Okay? It's a pay-as-you-go model. So if you want to have some sort of service, you only pay for the services that you're using. And the more of the service you use, the more you pay for. Okay? It is based on service-oriented computing, but not on the service-oriented architecture. So what do I mean by that? Well, let's look at 3 different delivery models, and hopefully this will start helping you to see those differences. Okay? First, you can have an infrastructure as a service. And one example of this is Amazon's cloud service called AWS. Amazon Web Services, which is what AWS stands for. It is and you can scroll down here to the different products and services. You can see that they offer a database as a service, computing as a service, storage as a service, networking as a service. Okay? These are what I mean by an infrastructure. They're providing database infrastructure, networking infrastructure, computing infrastructure, and storage infrastructure. And you only pay for the amount of database, computing, networking, storage that you use. Okay? You don't have to pay for things that you don't use. Now, that is an extremely useful thing for businesses that are in the process of growing. They don't want to have to buy a large database server like Oracle or Microsoft SQL Server when they don't have the funds to spend $10,000 on those computing services. Okay? Why buy a mainframe if you don't even need those capabilities? But wouldn't it be nice to have access to a mainframe just for a little bit, and then you just pay for that little bit that you use? Okay. The second level is called a platform as a service. And so here's an example offered by IBM. IBM has a PaaS, platform as a service. And so here's their IBM Smart Cloud Application Service is what they call it. Delivers secure, collaborative, cloud-based environment that fulfills a full lifecycle of accelerated application development, deployment, and delivery. Ooh, that's a mouthful. Essentially what they're doing is they're wrapping together all of their database, networking, computing services for you as a platform. You then can create your own software and put that software on their platform. Okay. And that gives you the capabilities, again, if you're developing, maybe you say you're an internet-based company who's developing or a software company developing a new piece of software, you don't know how popular the software is going to be, so you don't want to have to pay for large bandwidth that you may not need. And it's difficult to try to ramp up, as your product becomes more popular. Trying to then coordinate with 3 or 4 different vendors to grow with the usage of your software can be very difficult and very expensive. If you're working with a platform as a service provider, as your software usage or as your usage grows, you just pay more. And they already have the capabilities built in to grow with you. That is one of the beauties of a platform as a service. And the last one is something called as software as a service. And this is, someone provides a software for you as a business person to use. Okay? And now today, if you look online, and a lot of software companies are trying to move to this model, including even Microsoft. Like if you follow Microsoft's pricing models, they're working to convince businesses to move to a software as a service model. It helps Microsoft because they're going to be paid on an ongoing basis rather than as a lump sum when someone buys, let's say, Microsoft Office. So Microsoft has traditionally been having to continually come up with new products every single year or every few years in order to make a large amount of sales to keep growing. If they moved and had people use their software as a service, what they're wanting is people to pay them a regular fee, maybe once a month or once a year, for usage of their product. Now, then what Microsoft would do on the back end would be to continually update that software for you. So you would get the new enhancements immediately, and you wouldn't have to wait into these 5-year increments before you see the new updates. And then on the business side of things, software as a service is nice to be using software in that realm, in that you're only going to be paying for the software that you use as long as you use it. And if you stop using it, you can cancel. And oftentimes, a lot of these software as a service gives you the capability of downloading your data, so your data is not necessarily going to be trapped on this third-party server, but you can take it with you. Okay. Now, cloud computing can be either public or private, remotely hosted or internally hosted. Okay, so what do I mean by public or private? Well, you can create your very own software as a service internally for your business. So let's say I'm trying to think of a good example of this, because I read about a case study of this and now it's slipping my mind, and I hate when that happens, but let's take a hypothetical here, all right? So we're dealing with another large business with multiple lines of business, okay? And let's say one line of business creates a purchase order request form. They could create this piece of software and provide it as a service for all the other lines of business, okay? Hosted in the cloud, which means anyone else in the business can access that just within that business, and they can use that software. So you don't have to create independent pieces of software that then you deliver to all these separate computers. You put it one place on the computer, on the web server. That web server then offers that software out to everybody, and everybody can use it as they need to. Okay. in some sense, you can think of any web-based application as a software as a service. Some of them are just offered for free. Okay. All right, so how do they relate? Software as the service-oriented architecture and cloud computing are both part of the service-oriented architecture, or service-oriented computing. So service-oriented computing includes both of these, okay? So the idea of services, and now there is some overlap, so service-oriented architecture is going to be interested about providing these software in a cloud environment. Not all services are internet-based, but all cloud computing is internet-based, okay? Service-oriented architecture is interested in the enterprise-level approach to development and management of services. Cloud computing, although oftentimes enterprise-level in discussions, is really a specific technology or set of technologies for distributed service deployment and usage. Okay, so that's kind of the similarities and differences between these two here. All right. What else can we say about these? All right. So today, most CIOs are exploring or implementing service-oriented architecture and/or cloud computing. The big concerns with cloud computing is security and reliability. I just saw a news article recently about some of the backlash from Amazon, who had a power outage on their cloud computing platform. And the reliability, well, guess what? If your computing needs are being met by a third party, you're always going to be held to that third party's quality of service. Okay. Now you would hope that they would have a very, very good infrastructure that can stay and provide you with that service 99.999% of the time. Okay, that's your hope, but you're always going to be susceptible to issues like that. And in security, you automatically in cloud computing are giving some of your data to somebody else. You no longer have complete control of your own data. Okay, it is in somebody else's server on someone else's network, and you have to make sure that this information that's being transferred isn't accessible or isn't available to anybody else. And you might even be worried that your cloud computing provider, well, they have lots of employees, and hopefully those employees are all honest and trustworthy, but how do you really know? Maybe they're not. Maybe they're looking at your data, not just somebody who broke into the services. Okay, so there is much concern with security and still a lot of concern with the liability. And cloud computing reminds me of a technology that developed back in the 70s that was along the same lines. It was essentially the capabilities of buying a mainframe software time. And that technology was really a big push back in that day, and it flopped miserably. Okay, I would say that there's a similar concern today that even though cloud computing has a lot of promise, there's still the two major issues: security and reliability. And we just don't know, is this really a worthwhile, worth our money to put into it? Because a new technology could come along in a year or two that drops the price of any type of computing hardware to make the financial side of cloud computing absolutely ridiculous as far as feasibility. All right, major concerns with service-oriented architecture. Well, one big concern is that by providing things as a service, you're making it less efficient, necessarily creating additional processing. Okay, now oftentimes that's acceptable because, well, let's face it, computing hardware and computing hardware isn't extremely expensive, so it's easy to upgrade, especially compared to where it was. I mean, with the, with Moore's Law and everything, even though Moore's Law only applies to the number of transistors on a chip, the price of computing has been continually dropping drastically ever since the 1950s. So the cost of processing isn't exactly high, okay? But there is still that concern that every time you add more and more service-oriented computing, you need additional processing requirements, okay? There's also a major concern with interoperability. Yes, there is some interoperability that's actually enabled by the service-oriented architecture, but there's also great deal of difficulty dealing with changing services over time and how to keep all these services working with each other, okay? Because now you're having a vastly more complex environment and a vast increase in the number of services talking to each other, that changing one of them could have drastic repercussions somewhere down the road. And it could be something as simple as changing the data type accepted by one service from, let's say, a number with 8 digits to a number with 10 digits, or vice versa. And lastly, another concern is the security of services, because now what you're doing is you're opening up a lot of functionality to other people to use. And you might try very hard to cover all the security bases for each piece, for software, but now it's not in itself. Now you don't have, like with a program, an old-fashioned program, a lot of the code inside of it, you didn't have to worry about security, right? A lot of it was, self-contained. It was like a black box, and all you had to do was worry about the edges. Well, now with services, you've basically taken that black box and you split it up into 50 smaller black boxes, and now you have 50 more edges that you have to worry about. So it's very easy to miss something, which can open a security hole, and that is the really danger another huge danger of services. All right. Well, those are the two things that today is really set the backbone for enabling the capabilities of B2B commerce. So with services, now you can offer services like e-commerce services. You can offer all kinds of platforms or software as a service to other businesses, to consumers, all across the board. Chapter 5 gets into a few other major technologies, in particular EDI, extranets, marketplaces, and they even talk a little bit about RFID, which isn't strictly internet-based. I'm actually a little surprised by the inclusion of it in the book, because it really doesn't have anything to do with e-commerce directly, but it does have a fair amount to do with it indirectly. And so I'll spend a little bit of time talking about RFID, but I want to spend most of my time talking about the other three. Now, why is B2B commerce so important? Consider this. As big as business-to-consumer e-commerce is today, B2B commerce, e-commerce, is estimated to be 10 times larger, which means most businesses today do a lot more business with each other electronically than you might ever imagine. And if you go to any major business, you're going to see all different types of platforms for conducting e-commerce online with other businesses. So let's talk about a few of these major technologies. Okay. Well, before I jump into that, let's just take a look at why this is so important to understand these technologies. And it starts with the data processing requirements that exist now in most businesses. And so just to give you a little idea of why this is so huge, and it really happened, this historically happened in the late 1800s, early 1900s, the business world transformed through two major technologies. One was the railroad, and number two, the telegraph, which then evolved into the telephone. So what these two things allowed businesses to do, and they did it very, very rapidly, is they went from 21 factory businesses, so you have 20 different businesses all owning one factory, to where they started consolidating on grand scales to become one 20 factory business. And so what happens in these businesses? What are the data processing requirements? Well, they skyrocketed. What would you do if you had this, all these different activities? How could you manage all this, okay? And yeah, they try to develop business processes to make these far more efficient. And usually they centralize this through, mail rooms, and different ways of sending communications, but you still have a lot of processing that's occurring. The first major accounting machines really developed in the early 1900s to try to overcome a lot of this. And those early accounting machines developed into the first mainframes. But even then, so you have a mainframe to do your number crunching, but you still have a lot of data you want to share with your suppliers and customers. And that's where electronic data interchange developed. It really actually started developing in the 1960s in a very fragmented form, okay? So the internet started in 1969. But as I mentioned then, that there were networks before then, very primitive, very simple networks, but there were networks. And EDI was one of the major things they were doing it back then, okay? It is a system for sending electronic forms between companies. So rather than filling out, a purchase order or a request for a proposal, which is called an RFQ, or sending back another form, a confirmation of a purchase, okay, or a bill, okay. A lot of different types of forms you can send. Well, wouldn't it be great if we could send those electronically, and not just by fax? I'm talking about an electronically built form for sending things back and forth. So what did it used to look like before EDI? So you would have the buyer on one side and the vendor on the other. You'd have to mail all these different documents back and forth, and even within the business itself. So the buyer might have a purchasing department, which sends a purchase order through the mailroom. Then the mailroom sends it through the mail. The vendor has their own mailroom where they accept it, and then from the mailroom it goes back to their sales department, and the sales department has to split up that purchase order. One is a work order, one's a sale order, and you can follow this path going all over 2 different organizations, tons of information being sent back and forth. This is very, very complex, okay? And it's very easy for somewhere along one of these paths for an error to be made, for a form to get lost. And just the sheer volume of it was flooding mail rooms in the 50s and 60s. Okay, and so electronic data interchange was the idea to help with this process, to help ease the flood of information, to reduce the number of errors, and to make this process far more efficient. So what happened? And here's just a quick kind of overview of what it kind of looks like. So from a buyer's perspective, now they have electronic information sending from the operating unit who wants to buy something, sends it to the purchasing department. Instead of the purchase requisition being inside of a physical form, it's sent electronically. And the purchasing department sends an electronic signal all the way to the vendor with their purchase order. Okay, and then the vendor can see it and send an electronic form back. And so on. So all this is being done electronically. The forms are flowing quickly, and sales are wonderful for both sides. Okay, at least in theory. All right, EDI benefits. Great deal increase in speed of purchasing because you don't have to, a physical form doesn't have to pass through 20 different hands until it gets to where it needs to be. There's a reduced cost of the mailroom. Okay, and then today the mail rooms are actually fairly small, in all things considered. Okay, not the massive things that they used to be. We have a great reduction in human errors because there's a lot less times of people transferring forms or moving handwriting from one form to the next. And you also reduce the chance that someone along the line is padding it just a little bit and trying to induce a little positive income for themselves. Okay? Commonly known as fraud. All right, so EDI networks are really freaking phenomenal for a lot of businesses, but as they started to grow, and throughout the 70s and 80s, you saw these, they started realizing there's some limitations. Okay, so these bilateral EDIs were very useful, so between the buyer and vendor. But what happens if each vendor and customer wants a different standard for their EDI transactions? Sometimes one vendor or one customer was big enough to demand it of everybody to follow the same standard, but that's not always true. Well, that is where the idea of a value-added networks developed. Okay, and essentially this is one network that does all the major forms, and you simply plug into the network. So your business, either as a customer or as a vendor, you plug into one of these value-added networks, and then you now can communicate with all the other vendors and customers using that same technology, rather than having different standards for a lot of different companies. Okay, it saves a ton of money. That's the main value added from that. Okay. All right, extranets, what are they? Well, sometimes when you're working, the EDIs were nice, but you also, that's good for maybe perhaps all of your customers or all of your suppliers. Sometimes you want to develop a much more intimate relationship and share much more information than is traditionally done through the EDI network. So an extranet was this idea that developed to allow this to happen. Right? So it can improve a great deal of efficiencies in your logistics and planning, reducing the probability of overproduction, underproduction, and needless storage. And so a couple examples of this that I'm familiar with. One is Dell computers. And one thing that they did, now Dell was known worldwide as one of the leaders for driving down the amount of supplies that they had in their warehouse to practically a few hours worth. What do I mean by that? They wanted to have their manufacturing facilities basically receive supplies just in time to put them together to create their end product. And so the less storage space they needed, the better. Now they had to work very closely with their suppliers in order for this to happen. In order for them to receive the components they need to create their computers, to manufacture their computers. And so sometimes some of their components, they may only have a few hours worth of supplies. So if for some reason those supplies were cut off, they would have to stop manufacturing within, let's say, 2 hours. Now, do you see the problem with this? Okay. How does the supplier know how much information or how many products to send to Dell? Well, Dell basically started sharing all of their sales with them. So every time let's say you're buying a computer and you want a Bluetooth connectivity to it. Dell would then share with their Bluetooth manufacturers, their Bluetooth suppliers, that sale with them. So now that Bluetooth manufacturer knows that they need to create their Bluetooth component and have it on a truck shipped to Dell within a very short period of time. Okay, but they have this instant feedback. They know immediately what has been purchased, and so they can immediately adjust their production flow to basically mimic Dell's production flow. Both organizations when they developed these efficiencies in this just-in-time environment, were able to save money. And everyone ended up winning, okay? Another case of this, and I've heard about Lowe's, they have, and you've probably been to Lowe's, you may have seen, special kiosks where they sell, or a special area where they sell a certain type of product. Like in the painting area, they have a few brands that sell certain types of paint in those areas. Well, what Lowe's started doing was giving some of their suppliers their own section, and they could come in and put their own things in there. But then Lowe's would also share with these suppliers when those things sold from their section, so the suppliers know exactly how well their products are selling. And then the suppliers can immediately react to the sales information and change their production facilities to match what's actually being sold in certain areas. All right, so that's what it comes down to extranets, okay? You're sharing much more intimate information, usually things like direct sales. What had just sold today? And then the manufacturers, the suppliers of these organizations can immediately react and keep their manufacturing facilities in line with the actual sales. And so you have far less overproduction or underproduction. The storage needs, the number of warehouses greatly decrease. In fact, I remember seeing pictures from back in the 1920s and 1930s, and you may have seen these too. One that I was shocked is, I'm originally from St. Louis. The St. Louis riverfront used to be nothing but warehouses. Okay, as the river traffic would bring up goods and lots of goods and products, they dropped them off in these warehouses. Those warehouses are all gone, and they weren't really replaced. Now, where are things stored? Well, very, very rarely are they stored, but when they are in storage, it's usually on a truck being shipped from one location to another to be sold. And then, even in a lot of stores, the products, there's very little storage in stores except what's being displayed to sell. And then as they sell it, that information immediately goes back to the manufacturers so they know they can replace it. Or if something's not selling, they know not to produce much of it, right, and to make something else. So extranets are not just sending documents back and forth like EDI, but streams of data about very intimate information that's relevant to what's being done. Now you have to develop very close trusting relationship with these suppliers or these customers so that so that they don't basically cut in on your business. Okay, and that's the one danger of it. Okay, you're sharing information that they could use to basically work around you or to negotiate deals with other people. But it does allow your supply chain to be far more responsive and far more efficient. All right, another big topic, marketplaces. All right, a marketplace is basically a transaction-oriented portal for B2B commerce. It is far less formal than an EDI and not nearly as intimate as an extranet. Okay, focuses on transactions, not on logistics. And it's basically a place for people to come. You can think of it as similar to a catalog or an auction house or something in between. Okay, and there's a lot of different things that go in between here. So here's are different types of marketplaces, from seller-controlled industries to buyer-controlled industries, which range all the way from private stores on the seller sites, to customer portals, where there's a few sellers but many buyers, to completely independent industry marketplaces, where there's many sellers and many buyers. And that's kind of more of the true auction. Then you can have consortia-sponsored marketplaces. For example, a lot of the auto industry. So there's a few buyers, the car manufacturers, and many sellers of the car manufacturer parts, so the second-tier suppliers. They have their own marketplace. And then there's also private company marketplaces, where there's one buyer and many sellers. And a lot of variation in between here. All right. And that's really all we're going to talk about that. All right. And lastly, we're going to go ahead and radio frequency identification, also called RFID. These are chips that emit short distance radio signals. Each chip emits a slightly different signal, but uniquely identifies it. Used primarily in logistics. So again, it's not directly e-commerce, or at least internet-based commerce. It is electronic, and it does help with your commerce through logistics. So how can these be used? So here's a commercial I thought was quite clever and kind of funny. So we'll watch this.
Sir. You forgot your receipt.
Checkout lines. Who needs them?
Have a nice day.
This is the future of e-business.
All right, so do you see what just happened there? And this is really the idea of a different type of e-commerce in that, like I said, it's not internet-based. But that guy looked like he was shoplifting, right? And that was kind of the whole point of it. He was sticking all these things in all of his pockets, and then he just walked right out the store. But right at the end, before he walks out, he goes through this machine that identifies everything on his person, and probably even identified him in some way. Maybe he has a chip on his credit card that identifies him and allows him to pay immediately. Now, isn't that pretty sweet? Now, some people are a little scared by that concept. You know, what happens to these chips that are on? What if we take them off? Those chips. How do you deactivate the RFID chips after you've bought something? So it is not all the issues have been worked out yet. But the concept is eventually what businesses want to be able to do is, if they're selling products, they want to be able to put these chips on every single package to do many things, but including to make it very easy for you to check out of a store if you're buying these products, but also for things like inventory control. Now, it's very easy to control your inventory or to measure your inventory with all these RFID chips. So, for example, you have a truck that pulls into the back of the store. And if any of you have worked in any retail stores, you know what this is like. You walk into the truck, you pull off the pallets, and inside the pallet there's all these different products. What's on those pallets? Oftentimes they're labeled, but how do you know they didn't mislabel it? Well, if you have a bunch of RFID chips on each of the products, you can just wave a wand or walk it through a scanner, and it'll automatically read every single product that's on that pallet. And then immediately you can take that digital information and put it into your database so you know exactly what has entered your store. And then as people are checking out, you can scan them and see what's leaving the store. Or suppose you want to do an inventory count, where you go through the store and count each individual item in the store to make sure you have what you expect to have, that no one's been stealing things. Well, instead of having people walk around and touching and feeling everything, what you could do is have somebody walk around with a device that reads all the RFID chips in the store, and then you would immediately know what's still there. That would reduce things like counting inventory from a 4-hour job down to about a 1-hour job. And instead of 5 people doing it, you need 1 person doing it, walking around holding this scanner as they go. And it's all automatically entered in the database for you. that is a very powerful tool for dealing with logistics. Okay, it can keep track of things that are put on the trucks, taken off of trucks, in a warehouse, in a retail store, and can even help at the user end as you help people save time as they're checking out. Rather than having to swipe every individual item through a scanner, now you walk through one device and everything's scanned and automatically charged to your account. And bam, you can walk out, and saves you, let's see, how long does it take each day to check out of all these different stores? 5-10 minutes every single day. You won't have long lines. People just walk in, out, done. You don't have to, think about the time saved from a consumer standpoint, but also from the business standpoint, the logistics of how great it would be to be able to keep track of all your products, where they are in the store. Okay. So a very, very powerful technology. The price of the RFID chip has not come down enough to where we can put it on each individual product yet. Okay. They're getting there. The price isn't where we want it yet. But I would suspect within a few short years. Now, again, this is not directly internet-based. This is certainly electronically based commerce in that it's electrons on the radio frequency identification. But the implications for logistics are huge and what it can do. All right, so summary. We talked about service-oriented architecture and cloud computing, and how these two service-oriented computing one's a technology and one is an approach or a plan to dealing with service-oriented issues, are really important to CIOs today. And how do they create their business-to-business and their internal communications to effectively create a business platform. When working between different businesses, we have EDI, extranets, and marketplaces that are greatly facilitating these capabilities of selling information. And this is huge. It's over 10 times as big. Business-to-business e-commerce is 10 times bigger than business-to-consumer transactions. Okay, and if you think business to consumer is big, it's nothing compared to the B2B. And RFID is just a great new technology that's coming out that will greatly facilitate logistics. And as it does, you'll see its impact throughout the business world, including electronic commerce, and eventually even impacting our capabilities in into internet-based e-commerce. But that's into the future, and we'll be there soon enough. All right, that's all we got for today in Chapter 5. Come back next time for Chapter 6, and we'll keep marching on.